Hello and welcome to Quantum IAS. Today we are going to discuss the question that is posted for day 7 for daily answer writing program January. Let's get started with the question number 1. So question number 1 is saying a rubber cord of 1 millimeter in diameter, 1 meter long is fixed at one end. Weight of 1 kg is attached to the other end. If the Young's modulus of the rubber is given this much, find the period of vertical oscillation of the weight. Now you will be wondering how this can be possible. We have studied about the oscillation for a spring. Will it be doing the vertical oscillation for the weight? This is question number 1, right? So before coming to that question, we should write the introduction, right? What can we write in the introduction? We will come to this, whether it will oscillate or not, but what should be the introduction? So introduction is basically the Hooke's law, right? This should be our introduction because this question is directly from the Hooke's law, right? And Hooke's law is the link that you can relate between the spring as well as the rod. You can connect between the two, right? So basically Hooke's law states that the force or the restoring force is equals to minus kx, where k is the proportionality constant, right? K is the proportionality constant and x is the small displacement within the proportionality limit. Within the proportionality limit, right? So you need to write in the introduction, the Hooke's law states that force applied on an object is directly proportional to its displacement when the displacement is under its proportional limit, right? Now understand one thing, it is restoring nature. That means the net force on the rod will be zero at all the time. That will be always in equilibrium. So at equilibrium, it is occurring, right? From spring, mass spring system also we know that if we can talk about the mass spring system, we know that the time period is 2 pi root under m by k, right? If it displaces with a small amount, right? So if it displaces by x, the force acting on it and the gravitational force balances in such a way that it is always in the stable equilibrium and it oscillates through its mean position. That we know from our basic oscillations classes, right? So in introduction, you have to define Hooke's law. In Hooke's law, always define restoring force. What do you mean restoring force? The force which is trying to restore the original position of the rod or the element or the wire that we are talking about. K is the proportionality limit and x is the small displacement under the proportionality limit. And also you can draw the graph, right? So this is stress versus time, or you can say elongation, right? So up to proportionality limit, it works like that. And beyond, we have studied about the breaking point, yield point, all those things. That is not important here, but you need to write the Hooke's law and the limit till which we are talking this, right? Now, let us try to solve this question. So, this is the diagram you should be making. That this is M, this is L, let's say, right? And we have considered this to be elastic. This to be elastic. This is the wire that is elastic nature. And if it is elastic in nature, we can simply say that Young's modulus will be stress by strain. So let's say if it displaces by x, then strain will be x by L. Right? So from here, we can simply write K is equals to F by X. Minus just denoting that it is restoring nature. That means if X is in positive direction, F will be acting in the opposite direction. That we know that, right? But as far as magnitude is concerned, K will be equals to F by X. And this is the time period. It will be behaving like a spring. So we need to put the value of K here, right? So from here, you can simply write FL by AX. So from here, you can simply write F by X, and that is equals to K equals to YA by L, where Y is the Young's modulus. So time period, if you will find, time period will be 2 pi root under M by K. That is 2 pi root under M, and by K, that means this will come down. So it will be ML by. Now, important thing to note here that what you will conclude in the oscillation. So first of all, if you put the value, let's M it is given, L it is given, Young's model it is given, and area it is given. How area is given? Because they have given the diameter, so area will be equals to pi d square by 4. L is given, right? Mass is given, and Young's model is given. Just put the value. Time, whatever it comes, it will be small in magnitude, right? You can check it. That means the period of the oscillation will be very small, right? So this you can conclude in the your answer. First conclusion. Second conclusion, you can talk about T is inversely proportional to 1 upon. You can also make its graph, or you can interpret it. Because Young's modulus is the property of the material that we are taking, right? So as far as the wire is concerned, and because in some several instances or situation, we have to talk about the time period, right? In some cases, we need a large oscillation. In some cases, we want to reduce oscillation. So which type of material we should take for that, that depends upon the Young's modulus, right? So if Young's modulus will be higher, time period will be lesser, right? Young's modulus higher, that means it is more elastic. That means it can retain its original shape in a more better way than the other, right? So all those points can be written in the conclusion, right? T depends upon mass, length, area. That is not of much significance, because understand, the selection of the material is more important aspect in any of the design, right? Because according to your need, you can always adjust the geometry. So I think this variation of time period with the Young's modulus is more desirable to talk in the conclusion, right? So that's all for the first question, and I guess it was an easy question. Let's talk about the second question. Question number 2. So question number 2 talk about a light rod of length 100 centimeter is suspended from the ceiling horizontally. Please pay attention here. So it is horizontally mentioned here. Means of two vertical wires of equal length, right? One wire is of steel, cross section area is given, and one area of brass, other of brass, also whose cross section is given. Find the position of the rod at which a weight may be hung to produce equal stress in both wire and equal strain in the both wire. Now we need to make this. See, in the classes we have already discussed about these things. Give me 1 second. Some information is missing here. So Young's modulus of brass is given 1.0 into 10 to the power 11 Newton per meter square. Please add this information along with your question. It was misprinted here. And Young's modulus of steel was given as 2.0 into 10 to the power 11 Newton per meter per square, right? It was a recent PYQ question from the PYQ. You can check it there also. It was mentioned there. Okay. So in the introduction, we will talk about stress, strain, and their relation. Stress by strain, right? So we will define first stress, then strain, then their relationship, right? So how you will write in the introduction? So you should write, if a rigid body is under its equilibrium position, right? And when we said that a rigid body in equilibrium, please pay attention here. This is very important. The rigid body in equilibrium means that it will be in translational equilibrium as well as it will be in rotational equilibrium. That means translational equilibrium can be achieved at if net external force acting on it is 0, and rotational if torque net external acting on it is 0. So if I'm saying that, because it is a rigid body, it is a rod, you can see here in the question, it is mentioned over here, a light rod, right? So you will write, when a rigid body is in equilibrium condition and it is when it is acted upon by equal forces or torque, it will try to deform the body, right? To resist that, body will develop the restoring torque as well as restoring force that results in the stress in the body. Okay. Also, due to that stress, there will be small change in the dimension, and the ratio of the change in dimension to the original dimension is known as strain. Okay. These stress and strain will depend upon the type of material that we are using, and it will be depicted or can be seen by its Young's modulus or modulus of elasticity, which is mathematically written as gamma equals to stress by strain. This is the exact statement or similar kind of statement you can use in the introduction. After writing these statements in the introduction, see, I am dictating and I am supposing that you are writing these things and you are adding your own value added point to make your own definition, own introduction, right? Do not always look upon that I will write everything. So I'm dictating, please try to write all those things. It is also in recorded format, so you can just keep a backward of the video and you can just write all these things. Always write in your own word, but it should be complete. Now let us solve this question. So this is the situation. Here is a light rod and it is supported by two weight. Let's say this is of steel and this is of brass. This is of steel and this is of brass. Now a weight is needed to attach here. Let's say mass M. Doesn't make any sense. X, let tell element X, where L is the length of the rod, right? L is mentioned over here. You can check here. L is given. Length is 100 centimeter. So L is 100 centimeter. You need to put the values. I'm just solving the question for you. Now, if the body is subjected under equilibrium position, then only it can feel the stress or strain. Always know this thing. If it is not under equilibrium condition, it will accelerate or it will rotate. There will be always a change in the motion, right? The body will deform in only that cases when the change in the motion is not desirable or it cannot be possible. Always remember this thing. Now here it will apply attention. Let's say TA, TS for steel, let's say TS, and for brass TB, right? This wire will also has a cross-sectional area. We will see that also, right? Now to be in equilibrium, translational equilibrium, we can simply add TA plus TB equals to mg. Here it is mg. It is a light rod. They have mentioned already. It is a light rod. So the weight that we have added it equals to mg. So Ta plus Tb equals to mg, right? It will be not much helpful in solving the question, but you have to write this because this condition need also to be fulfilled. That is very important. Now, from here, T net. So let us talk about T about this point O. So if you talk about T about O, then you can simply write it will be 0. Net torque will be 0, and it is equals to TS, right? It will rotate in this way and it will rotate in this way. So both the torque will be in opposite direction. So TS into X minus TB into L minus X equals to 0. So from here you will get one relation, that is L minus X upon X, okay, is equals to TS upon TB. Right? If you put the values here, you can simply get the X value. If you can know the relation between TS and TB, you can simply get the X value, right? Now we will solve the first condition. Equal stress. So when there will be equal stress, then we can simply say that TS by AS is equals to TB by AB. This is only the tension, the force acting on the rod, sorry, on the wire upon the cross-section area, that is the stress. We know that. So from here, we can simply write that TS by TB is AS by AB, right? So TS by TB will be how much? AS by AB. You can see that. That is AS and it is AB. So AS by AB 0.5 by 1, that is 5. So you can simply put the value. So TS by TB equals to 5. So put the value. L minus X by X equals to 5. You can easily get the value of X. Right? It is your job to do that. I'm just discussing thing. So in the first cases, L minus X by X or the L or the X depends upon TS by TB ratio only. Right? This you need to conclude. Okay. First thing, this you need to conclude. Second thing, for equal strain. So what is strain? If you know the stress and if you have the Young's modulus, stress by strain. So strain will go upside, stress by Y. So it is simply TS by AS YS, TB by AB YB. So what will be TS by TB? It is AS by YS, AB by YB. So again, second conclusion, this will be YS and YB is also given 1 and 2, 1 by 2, 5 by 2, whatever it comes. That you can simply, it is a simple multiplication of 5 and 2 that you can do. I am more interested in the conclusion part. We have talked about the introduction. We have already solved this question, right? I guess everyone can solve this question, right? It is L minus X minus 1 equals to 5. So you can simply easily solve the value of X. Now, conclusion will be 2 here. For equal stress, it depends upon the ratio of the forces acting on it only. That is the important thing. Or the cross-section area. But for the equal strain, it depends upon the cross-section area as well as strength or modulus of elasticity. That is the Young's modulus. Right? Now understand one thing. When you can check that there are two different conditions. The value of X depending upon which situation we are choosing, equal stress or equal strain, right? Why it is happening? Because both the wire is made up of different material. If the both wire that we have chosen, it will be same material, that is YS and YB equal, then we will find only one solution, that will be unique solution of X. When the both material will be same, at that point only we will have equal stress and equal strain in the both wire. But if the wire that we are using will be different, then we will have two different position of X. for different condition of equal stresses and equal strain, right? So depending upon the situation, depending upon the parameter or the requirement, we choose this accordingly, right? So in conclusion, you have to write about the ratios, and also you have to talk about the material property. When YS and YB will be equal, or any Y1 or Y2 will be equal, then we will have only one position where the equal stress and equal strain will be that much can be written over here, right? Okay, so that's it for the discussion of the day, right? I hope all of you are writing the question and also posting on the website. Please, if you're not doing, please do so, right? If you are writing the question for regularly for 1 month, you will see a great difference in your answer writing skill, right? Okay, so we will meet on day 8. Till then, good night. Bye bye. Thank you.